Okay, so for the following one, we see that the question tells us that it's been in position A for a very long time, and at t, when it's equal to 0, the switch moves to B, and then we have to find Vt for when t is greater than 0, and then calculate what V is when t is 1, when t is at 1, and when t is at 4. Now, what's interesting is that we have two sources here, and this plays a role into our equation. Since so pretty much the previous circuits, when you would switch them, there would be like the circuit would turn into a new circuit that didn't have a source, and we would use like the following equation. It would be like something like V t equals V v at 0 times e to the power of negative t over the time constant. But in this case, this is not applicable because we have these two sources here, and when we flip the switch, one of these sources still remains. Like both of them don't go away if we have have our switch moved at a certain point. So I'll get to like what we do like afterwards. But for now, we need to find the following: t sorry, when time is infinity, what's the voltage going to be, and when time is 0, what's the voltage going to be. This is going to be play a crucial role in our formula. So right now, let's write the equation. Sorry, let's write the circuit for when time is less than 0. So when time is less than 0, we can just ignore this portion of the circuit. So we'll just have this port. Let me actually write it down here. So it'll be this portion of the circuit. So this is 3000 ohms, 5000 ohms. This is 24 volts. And then this is 0.5 millifards. Okay, the capacitor. So 0.5 millifards, that's 0.0004 fards. Sorry, 5 fards. Okay. Now we should find what this V value is going to be. Okay. Now, uh, since we were told that this has been closed, sorry, we're told that it's been like this for a very long time. So we're going to assume that it's been like this. Um, Actually, let me just show you this instead. So to find the current passing through here, through a capacitor, it's going to be the capacitor, sorry, it's going to be the current equals the capacitor times the change in voltage or over the change in time. And since we're told time has been a very long time, we're going to take time to be infinity. So that means the current passing through here will be 0. That means we can pretty much ignore this portion of the circuit. Okay, but even though we're ignoring this portion of the circuit, there's still a voltage here. Even though the current is 0, the voltage is still something. That means we should find the voltage at this region. So we'll do a mesh. Let's call this mesh I1. That'll be minus 24 plus 3000 I1 plus 5000 I1 equals 0. So let's solve for I1. Okay, so I get I1 to be 0.003 amps. And pretty much V will be equal to the voltage at this resistor. So V will be equal to 5000 times I1, so 0.003. And this will give me 15 volts. Okay? So when T is less than 0, V is equal to 15 volts. So that's good. And we can use this information to find T at, sorry, we can use this information to find the voltage when T is equal to 0. It's going to be also 15 because when T is equal to 0, we move this switch to here. But the voltage at this capacitor, it doesn't change instantaneously. So when T was less than 0, the voltage at this capacitor was 15 volts. Now when we change the switch at t equals 0, the voltage is still 15. Okay, and now we're going to assume more time has passed. So now we have to find v when t is infinite. So let's do this. Okay, so we can find v uh, at, when t is greater than 0. Okay, so right now we have the circuit that looks like this. So this is 4,000 ohms. This is 30 volts. I think that it was 0.0005 fards. Okay, so now we pretty much did the same thing again. Okay, so this is going to be open wire here, because like I said, the current is equal to the capacitor value times the change in voltage over the change in time. And since we're going to a really high since we're going to be waiting for a really long time, t will be infinite, so the current will be 0. Okay, so I will be 0, and since I is 0, the whole current through here is also going to be 0. So that means this resistor is technically useless. But even though I is 0, there's still a voltage here, and this voltage will equal to this 30 volts here, because that's the only volt source here. So that's what V infinite is going to be. Okay, now we just need one more thing, our time constant. So recall our time constant will be the resistance equivalent between the terminals here and here of our capacitor. And since we want the time constant when t is greater than 0, so we're going to focus on this portion of the circuit. So let's redraw our resistor value here and find, let me also erase all of this. And let's find the resistance equivalent through here. So this is 4,000 ohms. We turn off all independent sources. So this one we will just leave it in short circuit. So the resistance equivalent will be 4,000 ohms. So the time constant will be the resistance equivalent times the capacitor value. So it'll be 4,000 times the capacitor value, which is 0.0005. Let me just double check that. Yep, times 4,000. So the time constant is 2. And now we have enough information to find this mysterious formula I have been telling you guys about. Alright, so this formula looks like this. So Vt will be equal to V infinity plus V of 0 minus V infinity times e to the power of t over the time constant. So this formula is used when, if you were to flip the switch but still have some source like in your circuit. Okay, if you recall, like the other circuits, when we flipped a switch, either the source was gone, or like the previous circuit before we switched it didn't have a source, and then when we changed the switch, then it had a source. So pretty much there was a source in one of the circuits, and there was no source in the other circuit when we flipped the switch. But in this case, whether we flip the switch or not, there's like still one source involved. So since there's at least one source involved when we flip the switch, we're going to be using this formula. So Vt is equal to V infinity, which is 30, plus V0, which is 15 minus 30, times e to the power of t over the time constant 2. So it'll be 30 minus 15 e minus 0.5 t. And this is in volts. And this is your final answer.